Hello, it's KStevMath again here with another Algebra 1 video. So we've gone through solving one-step equations. We've gone through solving two-step equations. You may be asking yourself, is it now time for three-step equations? And my answer is kind of. I guess if there are three-step equations as like a class of equations, that this would be what we would call them. But really after two-step, we just call them multi-step. And so today specifically what we're going to look at, you can see on the screen, is solving equations where there's a variable on each side of the equation. And so once we add this to our solving equations tool belt, we've really just got kind of one more way in which we could make these linear equations more complicated, and at that point we just call them multi-step equations. And that's partially because one step, two step, and even this lesson, there's kind of a best way of doing these equations for the most part, not always, but there's kind of a best way to do it. Whereas with multi-step, you could maybe do it in 3 steps or 5 steps depending on your approach. So that's why we had just used that word multi-step instead of 3-step and 4-step and 5-step. That would be kind of ridiculous to name things like that. Anyway, let's warm up first and get a feel for what it is we're going to be required to do, since there's going to be a variable on both sides of our equation. Before we get started on the warm-up, if you aren't already aware, I have a notes page to go with this that you can get off of my website, KStevMath.com, link in the description. That way you don't have to write down every single thing, and just having kind of a notes outline to help you as you're learning how to take notes in math can be really helpful. Can help you organize your thoughts, your notes, and all of that. So if you need to pause and head over there and print it, that sounds like a great idea to me. This warm-up, I picked the topic here because it's going to be important to us as we're solving these equations. It is a concept that you should have seen prior to now in your pre-algebra class. And so if it's not seeming familiar to you, that's fine. That's why we're going to go over it. If it does seem familiar to you, then pause the video and give it a try and then start it back up so that you can see how you did. So on this first one, 5x plus 7x, we are being asked to add like terms basically. That's what we call these things. 5x here is a term and 7x is a term. And if you were watching one of the video before this about two-step equations, it can be helpful to think of this idea of like the 5 and the x together are a thing, and the 7 and the x together are a thing. And it also can be helpful to think of it like an x is a unit or an actual thing, that you're saying, I have 5 xylophones, and I'm going to add to that 7 xylophones. And how many xylophones will I then have? If you didn't catch why I used the word xylophone, it's one of the only words that I know that starts with X that would fit in a situation like this. Which, anyway, so 5 x's plus 7 x's. How many x's do you have? You have 12 x's, and depending on what you remember from pre-algebra, we're not going to put an x squared because we added x's together and we still get x, not something different. We don't drop the x from it. We just add the numbers in front and we continue to use the x next to it. So let's look at number 2. We have 9y minus 3y. Now what could we use for y? What starts with y? Yak. Okay, if we have 9 yaks and maybe we give 3 of those yaks to our friend because we want to share yaks with other people, then how many yaks do we have? 9y minus 3y, you subtract those two terms and you get 6y. And again on this, it's this idea of like terms. We were able to subtract these because they're talking about the same thing. They're both talking about y's or they're both talking about x's. If we had a mixture of letters, either by accident because I typed it wrong or on purpose to prove a point, we can't combine those things. Or like in number 3 where we've got some things with x's and something without x's, this creates unlike terms. So in 3, as I'm looking at this, I would look through and say, okay, well I've got a 6x, I've got this x right here, and I've got this 2x, which we need to think of as a minus 2x. That sign in front of 2x is attached to the 2 and the x. So we can put those x's together, and then we can also put our numbers together, 1 and -5 and +7. But what we can't do is we can't combine x's with just numbers that don't have x's because they're not like terms. This can be a really tricky thing to get at first, but I think once you get the hang of that idea of what you're looking for that's like terms and what's not like terms, I think it ends up being pretty easy. So we're going to add these together, and incidentally, if you are struggling with this, I do have a video which I will link in the description, and also have a thing hopefully pop up right now that will tell you where to go to see it, so that you can practice this. I have a video and I have a little app on my website so that you can practice it and make sure you're good at it if that's something you need. Another thing to mention real quick is this plus x right here is a 1x. We'd put a 1 in front of x right here. This is a 1x. All right, that's a really terrible looking 1, but it is a 1 nonetheless. So we're going to do 6x plus 1x, that is 7x. And then we're going to do 7x minus 2x. We could organize our work here in a variety of ways. We could actually write this vertically, and maybe it's helpful to put the signs. We could do something like that. We could rewrite the x's separately but have them be horizontal. Or we could just look at the problem itself and say, okay, I can keep track of this in my head. So either way, we should be getting 5 x's are left, because 6x plus 1x is 7x, minus 2x is 5x. Now we're going to take the numbers and put them together. So we've got a 1, a minus 5, and a plus 7. And if you think of this as a -5, you can do this in whatever order you want. And what I mean by that is saying that this is 1 plus -5 plus 7 allows us to pick and choose what we want to do. Because subtraction, you have to do from left to right. But if it's addition, I can pick and choose. So I could do 1 plus 7 first and get 8, and then do 8 plus -5, which is 3, because that's the same as just 8 minus 5. If you are struggling with positive and negative numbers, I don't at the time of this video have another video and an app to help out with this, but I plan to at some point, so hopefully something pops up, or hopefully there is a link in the description, because the way YouTube works, I can edit the description and the things that pop up, hopefully for forever. Anyway, so we get 8 minus 5 is 3, so this would be 5x plus 3. So that's how we add and subtract like terms. It's just a friendly reminder before we get started with today's thing, which is solving equations with variables on both sides. Alright, so here is an example of what we're even talking about when we talk about an equation that has a variable on both sides. We're still talking about linear equations, so we shouldn't see any exponents or anything weird going on with our equation that we haven't already seen. But what should look different is that on the left side there's an x, and on the right side there's also an x. And for actually solving an equation like this, they should be the same variable. You shouldn't have a mixture of letters, because that makes things more complicated. We'll get there later, but we're not ready for it yet. So what do I do differently because there's a variable on both sides? Remember that we've got these algebraic properties of equality that we can use. We can add things to both sides. We can subtract things from both sides. As long as we do the same thing on both sides, then we've maintained equality, and so it's allowed. We can, we have to remember what our goal is in an equation. We're trying to get x by itself, and so the issue here should be that, okay, well, we've got more than one x. Which x do I get by itself, or how do I get the x's by itself? And what we're going to do is we're going to start off by putting the x's together, either on the left side or the right side. It actually doesn't matter which one you choose, but we're going to put the x's together as a first step. And then the rest of the equation solving is going to be exactly like what we did in our two-step equations. So like I said, this is basically like three-step equations, because we just have one thing we have to do before they're just like what we've already done. So how you decide which way to move your x's could either be you always do the same thing, and I've got a couple options if that's what you like to do, or you can just kind of decide however you want. That's not really my thing, but I guess some people like to live dangerously. So a pretty accepted practice is to look at your x's, which here I've got 5x and 7x, and to say, I want to put those together in such a way that I still get a positive number. And that's only because we struggle more when we deal with negative numbers than we do when we deal with positive numbers. So if you want your best chance of success here, it would be probably to have as few negatives as possible in real life and in math and in English. But anyway, so if that's what I want to do, then I should move the 5x over to the right side, because if I subtract 5x from both sides, I'll still have a positive number of x's. Whereas if I subtract the 7x over, that's going to give me a negative number of x's. But it doesn't actually matter which one you choose, because the other option you have is just to always move the x over to the left side, and there's actually some value in doing that because it can be helpful whenever you're dealing with inequalities later on instead of equations. But it's really up to you how you want to do it. You just have to keep track of your numbers and you'll be fine. As long as you're doing it right, you can do it however you want to, which is probably one of the dumbest things I've ever actually said, so I apologize for that. Okay, so I'm going to move the 5x over to the right side. So I'm going to show my work so that you can see exactly what's happening. So I'm going to subtract 5x from both sides. Because I picked the same thing to subtract on both sides, I still have the same equality happening for this equation. That is an algebraic property that I just used, that I subtract 5x from both sides. And whenever I subtract it from each of these sides, all that gets affected are the terms with x's. So for instance, 5x minus 5x is going to be 0 x's, which in other words means 0, which means, hey, these go away, which is why I chose to do that. And it leaves me with negative 9 on the left side. Whereas on the right side, where we've got 7x plus 3, and now we're subtracting 5x, that 5x subtracts from the 7x and does not subtract from the 3. For two reasons. One, they're not like terms, and two, when we're subtracting from a side, it doesn't distribute. We don't have to subtract every single term by 5x. We just have to subtract the whole thing by 5x. And so because we can do 7x minus 5x, that's what we choose to do. And we get 2x. And then this plus 3 didn't have anything that affected it, so it gets dropped down and is plus 3. Now this should look like something we did last video or last lesson, where we're now trying to get x by itself, and we have to decide, do I want to mess with the 2 first or the 3 first, because both of those are on the same side as our x. And we always deal with what's closest to x last, so that 2 needs to be dealt with last. I'm going to take the plus 3 and I'm going to say, how do I move a plus 3 away from this? How do I make it be 0 essentially? I do that by subtracting 3 on both sides. Like so. And then now that all that's left next to x is 2, I can very easily divide both sides by 2, and I will know what x is. So x equals negative 12 divided by 2 is 6 with a negative, because if one of these two is negative, it makes the whole thing negative. So x equals negative 6. And I personally am totally fine with leaving it like this. We could also flip these around and say it's x equals negative 6. That is I think it's the symmetric property of equality that lets us do that, but it's something that's always true. You can always flip the sides of the equations if you want to. So if you're like, wow, it looks so much better with the x on the left, by all means go for it. This is just in general how we do this type of problem. So now that you've seen one done, it may be that you're ready to go and do it yourself. So I've got more examples to walk through. And if at any point you're looking at one of these examples and saying, I think I know how to do this, feel free to stop the video, give it a try, start up the video when you get stuck or when you're ready to see if you got it right. Because it's really important, and I posted a video recently about how we learn math. It's really important for you to be able to see that you're doing it right step by step. And the best way to do that through the internet and YouTube like this is for you to try it, maybe do a step, play the part of the video with that step and see if you got that step right. And if at any point you are confused about what I choose to do, feel free to leave me a comment below and I'll do my best to answer it as quickly as possible so that I can help you with that. So let's do some examples. Example 1. So if you feel like what we already did was enough for you to understand what's going on, this is a great opportunity, like I said, to pause the video, try it yourself, and then see what's happening once you've got it to a point where you're stuck or once you've got the answer. But if you still need more help, that's totally fine too. Lots of people need more than one example to be able to get something. I would say more than half of people, in fact, need more than one example. So in each of these, my goal is going to be to get the variable on one side, and that's it. That everything else will be on the other side. So here I've got a 6x and a 5x, and I want to put them together. It doesn't matter if I move the 6x over to the right or the 5x over to the left. All that matters is that I make a decision so that I'm not stuck perpetually looking at this problem. So my preference would be to move the 5x over to the left. In general, I like moving things to the left. Like I mentioned on the last one, I do also like getting positive numbers, so there are occasions where I move to the right. But in this case, I'm going to subtract the 5x over to the left side. And 6x minus 5x gives us 1x. You can write 1x, or since there's only 1x, you don't have to write the 1 at all anymore. You can just write x. We're going to drop down the minus 1, the equal sign, and the minus 10. And you need to pay attention to the details here, because if you forget to drop down the negatives or get confused about what numbers you're supposed to be writing down, obviously that can make this go sideways pretty fast. But now, this is a really easy equation to solve, assuming we got the last couple of lessons okay, because all I have is x and this minus 1, and so I just need to add that 1 over to the other side. So plus 1, and I get x equals, what is negative 10 plus 1? Since they have different signs, I actually subtract the two numbers, but because the 10 is bigger and is negative, it makes my answer negative. So negative 10 gets slightly more positive and becomes negative 9. So x equals negative 9. Let's look at b. Now we're using y. Both of the letters are y, which does matter. If one letter was y and one letter was x, this would be a much different problem. We'll get there, but not today. So I need to get the y's together. So I could either add 7y to both sides, or I could subtract 6y from both sides. Like I said, it doesn't actually matter which one you choose, but if you, like most of the world, prefer positive numbers to negative numbers, then we should add the 7y over to the right side, like so. That means I have 4 left right here. 6y plus 7y gives us 13y, and then the 17 gets dropped down. And then I say, okay, let's get this y by itself. We always save what's right next to y. This 13 is going to be last. I'm going to subtract the 17 over first, and you'll see a really neat thing happens here, that this becomes negative 13 equals 13y. And so when we divide both sides by 13, we get negative 1, because 13 goes into 13 exactly one time. But that negative makes our answer negative overall. So this has been example 1, technically 2 examples, right? Because we have an A and a B, so that's 2 problems. I have an example 2 that you are welcome to watch me work through, or you're welcome to try on your own and then check to see what the right answer is. And then after example 2, I also have a now you try. So if you're like, oh, I've already got it, you might skip ahead to the now you try. Whereas if you're still not sure you get it, just keep watching and hopefully you'll get it. For the most part, these examples don't really have anything new and tricky happening, but there is something that happens here on example 2A that you maybe would get thrown off by if you're doing it by yourself. I don't know. And so the idea of, if we want to make things positive if possible, how do I decide whether to move the negative 4a or the negative 3a? Because in both cases I'd add something. You would, if you're just aiming to make things positive overall, you'd want to add 4a over to the right side, because that's going to give us a positive 1a. as opposed to if I add the 3a over, then I'll still get a negative, right? Because 3a is not as big as negative 4a. Like I said, it would not matter. And in fact, just for funsies, let's not do that. So that if you forget or just accidentally add the wrong thing, or you are doing the just get everything on the left side thing, let's see how that would work out on this one. So if we just want to get everything on the left, or the a's specifically, if we want to get the a's on the left side, I'm going to add this 3a over, sorry about that plus sign, over, so negative 4a plus 3a leaves us with negative 1a. You can write negative 1a, or you could just write negative a, which means the same thing. It might help you to write the negative 1 instead of just negative a, but it's up to you. Then I'm going to take this negative 18 and I'm going to add 18 to both sides. If you haven't already noticed by now that this is fairly repetitive, we're doing kind of the same thing every single time. I hope you notice it soon. That is something that's helpful in math, that it's not like every problem is different. You practice problems until they're repetitive and until you've got the hang of it, so that when a new problem comes along that's harder, you already have a basis that's already in the back of your mind that you've accepted as how you do it, so that you're building constantly off of prior knowledge instead of constantly having to reinvent the idea of how to solve an equation. So negative 21 plus 18 gives you negative 3. If you wrote negative 1a equals negative 3, it should be hopefully pretty obvious. Well, I can divide both sides by negative 1, or you could multiply both sides by negative 1, or it could be that you just need to think, well, if I have negative a equals negative 3, then positive a should equal positive 3. However you want to go about thinking through that last step is fine, but we do have 3 kind of ways we can think of it. Dividing by negative 1, multiplying by negative 1, or just saying the negatives cancel each other out and leave us with positives. So that's why I wanted to move to the left to have that last line happen, where what do you do whenever you got a by itself, except that it's negative? You can't just stop and say negative a equals negative 3, because we want to know what positive a is. All right, let's look at b. We have a 4n on the left and a negative n on the right. We want to put those together. So I'm going to move them. I'm going to move the negative n by adding an n to both sides. And in case for whatever reason you decide not to watch the rest of the video, I do want to throw out there for those of you who like to show as little work as possible, which I mean in reality is technically all of us, I want to say, as human beings. You can actually combine the first 2 steps if you are being careful and feel like you have the understanding too. So what I mean by that is, since I'm adding the n over to the left side and making this go away, then I can know right away that, oh, the next thing I would do is add this 17 over to the right side, and so that we can do those in the same line and save ourselves some rewriting and some room on our paper. If you're like, okay, you totally lost me, that's fine. You may not be ready to do that yet. It's totally fine to show more work, but it's also fine if you're like, I'm getting the hang of this, I can do both of these at once. Eventually, hopefully you'll have done enough of these that you can be like, oh yeah, I can totally do these 2 things at the same time. It's very much I'm going to move this over here, I'm going to move this over here, and then we're good. All right, so 4n plus 1n is 5n. And negative 7 plus 17 is 10. And then we're just left to divide by 5. And it's actually really cool when we combine those steps, because, I don't know, it makes it feel like a lot shorter problem, I think. Because whenever I learn, as kind of a side note, if you're even still watching, when I was in Algebra 1, I remember my teacher talking about x's being like cows, and the numbers being sheep or something, the equal sign being a fence, and you want to get all your cows on one side and your sheep on the other. And so it's this idea of, okay, move the cows over to the left, move the sheep over to the right, and then, okay, now we just got to divide by that other number. I don't know if that's a helpful analogy to you. I found it helpful at the time, but, you know, whatever works for you. We need to get the variable alone on one side and the numbers alone on the other, so that we get an answer And in this case, that answer is n equals 2. The next thing that I've got going on is the now you try. If you've already been trying on your own and succeeding, you can probably skip this part. But if you want more practice where you'll know whether or not you got the right answer and potentially be able to figure out what your mistake was, then please continue to do it. And if you are feeling like you're ready to be done, skip to the end of the video to see what resources I have available to you on my website. Alright, now you try. So we've got 2 more problems that you can try on your own and see if you got the hang of this. Or you can just go ahead and skip to the end of the video to see what resources I have available to you. That's fine too. If you, before I forget, there is a challenge problem. So don't skip too far. Make sure you look at the challenge problem because it's challenging. So I want you to try these and then you can start it up and see how you're doing and see if you've got it or not. Alright, so I'll walk through this with you, and if you made a mistake or got stuck, hopefully you'll figure out what happened and learn from it. So I on A am going to take the negative 3x and I'm going to get rid of it. So I'm going to add 3x to both sides. Then on the next step, I'm going to want to take the number that's on the right and move it over to the left. So I can do that on a separate step, or I can do that on the same step. If I do it on the same step, it should look like this. So that I'm doing negative 12 plus 2, which is negative 10, and 2x plus 3x, which is 5x. So divide both sides by 5, and negative 10 divided by 5 is negative 2, and then we get x by itself. So x equals negative 2. And if that helped you figure out something new, feel free to pause the video and try B if you haven't already. If not, let's just keep going. So I'm going to be different this time, and I'm going to move the 9x over to the left, even though that is going to give me a negative number. If you did it the other way, that's fine. Hopefully either way we'll get, not hopefully, we should get the same answer, whichever way we decide to do it. But if you made a mistake and moved to the right, hopefully you'll still be able to figure out your mistake. So I'm going to subtract 9x from both sides and subtract 14 from both sides so that I get negative 8x equals 22 minus 14 is 8. So I divide both sides by negative 8 and I get a negative 1. So that's my answer. Hopefully you are feeling pretty good about this right now, but there's always more opportunity to practice and get better at it. And definitely feel free to leave a comment if something about this did not make sense to you, or if you think I made a mistake, or if you just can't find your mistake. Challenge time! Okay, so part of math is taking what you know how to do and trying to apply it to something new. So this problem is kind of similar to what we've been doing, but also kind of combines some things that we haven't had combined before. So I want you to give it a try and see how far you can get. If you get all the way to an answer, feel free to comment with your answer below. Or if you get stuck and want to leave a comment about what you tried and what you ended up with, leave a comment about that and I'll do my best to help you get through the rest of it. But if you're just like, I don't even know how to approach this, this is actually the kind of problem or one of the kinds of problems we're going to be solving in the next lesson that's about multi-step linear equations. So stay tuned for that video. That'll be coming up hopefully, next soon. Thanks so much for watching. Every time you watch one of my videos, I really appreciate it. And if you want to subscribe or like the video or comment, that'd be super awesome. Another cool thing you can do is go check out my website, which is on the screen right now, and I'm adding new stuff to that just about every day. Resources that you can use, or if you're a parent, you can use for your kids, or if you're a teacher, you can use for yourself in your classroom. But in particular for this lesson, if you go to the link in the description that goes specifically to like this lesson on the website, you'll see that I've got the video linked on there, and I've got an app that gives you practice questions and tells you the answer. I've also got a worksheet that you can use for practice as well. So you can go check those things out and hopefully get some use out of them and learn something new. Like I said, thanks so much for watching, and I look forward to seeing you in another video. Bye.